excerpts from a seminar I taught at AAA Hobbies on optimizing your box stock cars.
We're here at AAA Hobbies in Magnolia, New Jersey for our seminar, Optimizing Your Box Stock Tamiya Four-Wheel Drive Racer with Claire Din. So Claire,
Yes.
It's all yours.
Hello everybody, I'm Claire Din, and you might have seen me on YouTube. I'm on The World of Claire Din, which has mini four-wheel drive racing, yoga videos, since I'm a yoga champion also, bronze medalist in the USA. And what I do here is, for fun, one of my fun hobbies is building these mini four-wheel drive cars and racing them. So we have races on the East Coast, especially at AAA and other places as well, once a month during the racing season. And yeah, I'm going to show you how to build these cars, how to optimize them. I'm going to show you tried and true techniques that will help you increase and optimize the performance of the car. And I'm also going to show you some secret techniques that you may have never seen or heard before. And these little tricks and tips will help you get the most out of the four-wheel drive car. So, everybody's got a car in front of them right now, and you've opened up the box and checked out its contents. You'll see it's not that hard to build one of these things. If you just follow the instructions step by step, there are pictures, there are little details that are involved in every kit. You got the Cosmosonic. How many of you have the Cosmosonic? Good. And how many of you have this Panda Band? Either one is fine. Any of these other things are fine too. As you see here, we've got something that's very much like a Cosmosonic. This is an FMA car. This is the Brocken Gigant. This is also another FMA car, another FMA car. So FMA cars are pretty nice, pretty fast, pretty stable. Their motors are in the front of the car versus the rear of the car. There are certain performance differences between a front-mounted engine car versus a rear-mounted engine car. Typically over jumps, the front engine-mounted cars are a little bit more stable and solid than rear engine-mounted cars. There are also mid-engine cars where the motor is basically smack in the middle of the car, and that gives you a nice, even performance, whether you're jumping over hills or going around curves, things like that. So this is an all-around nice performance vehicle. However, usually the gears that are included in these cars are typically 4-to-1 gears. And 4-to-1 gears are great for complex tracks that, what do we call them, technical tracks, where you've got lots of turns, twists and turns, loops, things like that. Typically though, when you get larger wheels, you'll get a higher gear, 4-to-1 gear versus a 3.5-to-1 gear, which is typically what you get with medium-sized tire cars like this. So how many of you have medium-sized tire cars like this versus giant, chunky tire cars like this? Anybody know? Does anybody know the difference? You can see the difference here, large versus medium. So take a look at that. And there's also small. These are the small ones. These are actually smaller than the medium-sized ones. And nobody should have these unless you get like a specialty car. So yeah, big chunky tires, usually 4-to-1, 4.2-to-1 gear ratio. Medium-sized tires, you usually get 3.5-to-1 gear ratios. Then you can think about, like, once you get into this hobby enough, you'll think about the tune class category, which is building your cars with other optimizations, like aluminum rollers in the rear. You can think about adding carbon plates to strengthen the front and backs of the sides of the cars. You can add these weights, these things called mass dampers, which affect how your cars will perform after a jump, around turns, things like that. You want to weigh the car down when you're in tune class category because you're going so fast with these cars. These cars have upgraded motors in them in tune class category. But let's go back to box stock category. We have here an engine in every kit. Everybody, hold up your engines. I want to make sure that you all have engines. Good. Okay, awesome. So take the engine out of the bag right now and take a close look at it. I'll show you some details. Yeah, there is very simple anatomy to these engines. Everybody's got their engine out? Hold it up high. Good. How many have single shaft engines? That's just one of those rods sticking out. How many have dual shaft engines with 2 rods on either side? So how many have single shaft engines? Raise your hand.
We've got single. Just one rod coming off the
One rod coming out, just like this. And how many have dual shaft with 2? Okay. So there's differences, performance differences between single and dual shaft engines. So even though they might be rated at the same RPM, there's a higher torque output out of the dual shaft engine. So it doesn't mean that you're going to be faster than single shaft cars, but it will mean that there's more stability in the front and back ends. So you'll have a better performance for those, you'll have a better, more stable performance car with dual shaft engines. But it all depends on how you tune your engines. So right out of the box, you're going to get an engine that's like, it's going to be okay in performance. It's not going to be super, super awesome. There are things that you can do to tune these engines, to optimize them, to make them as fast as possible. And today, we're going to just get into some brief details on how to do that. But just taking these out of the package, you're going to get good to very good performance, but not optimal performance, unfortunately. The way to get optimal performance out of these engines is to tune them, and there are different methods of tuning these engines. We'll discuss them at a high level, and then we'll get a little bit deeper. So there's something called water tuning, where you actually dip this engine partially into water, and you're turning it on using DC voltage to try to get all the soot out of the engine. So that might be something that you may want to do, you may not want to do, right? The soot is dirt. So there's also ways of doing it using a dry method. You can also put drops of oil in the engine and hold it vertically, like so, while you attach the DC voltage to it. And DC voltage, all this means is you have like this external battery pack. You connect the positive and the negative on it. You can do it on either one of these leads, and then you run this whole motor for about a minute, and you drop little drops of oil into it, and you'll start seeing accumulation of soot mixed with oil coming out of your engine. You can basically tap it out. And you do this again and again. You reverse the polarity by switching the positive to the negative, negative to positive, and you go and you spin the motor again for a minute, and you do this oil technique. And you keep doing this until you get basically a clean motor. The whole idea is you want to get all of that soot out of the motor first, and then you'll get a very optimal engine. But just out of the box, you'll get something that's good to very good. And if you continue running your engine over time, you might get an output that's almost optimal. I mean, the more you run your car, the more you race your car, run your car, come to events like this, not this per se, the seminar, but coming to the racing events, you will be able to get a car that will, well, your motor will eventually get to that peak performance. But if you want to get your peak performance out of the box quickly, you'll want to tune your motors using the various methods. If you go onto my website, you'll see various tuning methods using water tuning, using oil drip tuning, dry tuning I call it, things like that. So today we're going to concentrate on building the car, optimizing what we have inside the car, and then when you get home, you can look up my videos and you can find out some more information about tuning motors.
Hey Claire, just to clarify, Claire's talking about the motor outside of the car. In other words, before you build the car, break the motor in and then put it into the car.
But you can also break it in afterwards, that's fine too. There's a way to break it in. You won't get 100% optimization, but it will be pretty much like 95% optimal. That's pretty good. That'll beat a lot of cars. So sorry, I'm sweating a little bit, so it's warm in here. So welcome, hello everybody. So,
It is.
all right. So everybody, you've got your tools, you've got your instructions. So what I want you to do is take the bodies of the car and start decorating them the way you want to decorate them using the pieces. Rip them off the rubber pieces off of the tire. You might see that there's a little dimple where it goes concave in, where it might actually stick out a little bit. Again, this is a manufacturing defect. So what can you do to counteract that? You can take your nippers and try to get as close as possible to clip off as much of the rubber as possible. You can also use this sanding file to file down the tire, but you don't want to keep filing. You don't want to file the tire all the way around with this as much as you can, because really it's against the rules to use this and sand your tire down too much. So the way to there's just manufacturing defects. The way to counterbalance all of this and to try to get an optimal car given the tires that you were given is when you're putting these on the shaft, these tires on the shaft, you're going to try to line up the bird components, the bird areas, to the bird areas. So for example, if I have two wheels, let me just set two off to show you. Okay, so let's say I've got the bumps of the tires facing upward. The bumps are facing upward, and they're also corresponding bumps facing downward because that's how these came off of this set of tires. So we're going to line them up so that they are in the same direction, top and bottom. Don't have one where the burrs are in the top, burrs are in the bottom on one, and then the burrs are facing you in that way. You have to try to line them up as much as you can, and that'll optimize the speed of your car with the tires. So this is a minor point. When you're filing this down, you can file with this perpendicular to the wheels, but also tilt it slightly over and get the sides too, the sides on both sides. So like 10, 20 degrees, and then file, 10, 20 degrees, and file. Get as smooth as you can around where those burrs are. You want to try to smooth out the burrs as much as you can. And you might think that all this little nitpicky, these nitpicky details don't mean much, but it actually does, because remember, think about it this way. A little imperfection, you magnify that by 32 times. It now becomes a big imperfection when you're dealing with real-life size vehicles. And we're talking about little miniaturized cars, right? So you want to be as precise as possible when you're building the process. So take your time building cars. They claim it takes about 45 minutes to an hour to build one of these cars. Really, if you're doing it properly, it's going to take well over an hour to build one of these cars. Probably more like an hour and a half to 2 hours. Okay, so everybody start placing your palm bearings into the sides of the car, and then we'll talk about adding the shafts. So you might find that one or more of your palm bearings won't fit precisely into your chassis. And if that's the case, try a different one, because it might be that one palm bearing might fit in very well in one part of the car, and another one will fit in better in another part. So you might be wondering why you have an extra palm bearing. There's 5 usually instead of 4. One of them will be used for the gear itself. If you have a 3.5 to 1 gear, or 3.7 to 1 gear, or 4 to 1 gear, you can actually place the remaining palm bearing into it, and it'll optimize the performance of that gear even better. Okay, does everybody have their palm bearings in their cars? Everybody raise your hand. Cool. So, some items that you might want to consider. Everybody's got this thing, this tube of grease right here. So, this is a good starter grease, but I actually prefer and recommend these 2 items here. So this is the Mini 4-wheel drive F grease, and this is the oil pen, which is here. So you don't need to get these things, but if you're going to race these in a serious way, then getting these 2 items is very necessary, because this is like the best lubrication that you can get for the components in the kit. Okay, so everybody locate your 2 shafts for the wheels. Hold them up. I want to make sure that everybody's got them. Cool.
Already got their wheel shafts? Yeah.
Okay, good. So, these come out of the factory generally straight, but not perfectly straight. Sometimes they're not straight. There's this thing called a wheel shaft checker that you can purchase. This is something that you can get offline. Unless you have something similar to that.
I don't know.
Okay. I can show
That's
you.
a new one on me.
Yeah.
You have to show me where to get those.
So,
That's not a Tamiya part.
yeah, it's not a Tamiya part. There are various third-party manufacturers that sell things like this. On occasion, you'll see a 324 is a company that sells things like this. But otherwise, you can purchase these from other sources, and if you're interested, then I can tell you after the class. But anyway, you basically place your shaft in here, and you angle it so that if it comes out smoothly, like you see here, that means it's a straight shaft, or a reasonably straight shaft. So test both shafts. Usually one is very straight, and the other one is not quite so straight. And I don't know why they do this. There, this one didn't even come out. So I have to use this shaft to actually push it through.
Check that.
Yes, so how to optimize this. Yep. So here's one method. This is just one method. You can use other methods. Everybody's got a phone. Right. Okay, I'm going to tell you right now. What I'm going to teach you now, it's not my fault if your phone gets messed up. I'm just telling you this as a guideline. So this is my warning. This is like my warning. Don't do this on a phone that you love. But you can also use something that you know is like a straight source that has light underneath it. So what I do is I like to place my shaft right on the phone, and I turn on the phone so that I can see light underneath the shaft. If I see that it looks pretty uniform, then I know it's straight. If I continue turning this, because this is a hex, these are called hex shafts, so they are 6-sided. So I'm going to turn this one time so that it lays on a different flat part of the hex shaft. And if I see light uniform underneath the phone, then I know it's straight. I'm going to do it one last time. because it's a hex shaft, 6 sides. You care about 3 of those 6 sides, right? Because so turn on the light, and it looks uniformly straight, reasonably straight, we're okay. Now how do you fix this if it looks a little crooked? Well, the ends of the phone are usually curved. So if we see something, if we lean on one side of the shaft, and we see that the other side of the shaft props up a little bit, we know it's a little crooked. So we take this, push it out a little bit, to the point where we can now see that it's uniform. That means the rest of the shaft is a little crooked. Then we just gently bend until we get the shaft straight. And if we bring this shaft back over, we should see that the shaft is uniformly straight. So that's one method to get your shaft a little bit straight. Now it's a gentle bend, and you're not trying to like yank it down or anything like that. It's a gentle bend, because this is a steel shaft, and it's thin enough so that you can actually bend it. But you don't want to bend it with force. You want to gently press so that you get the bend out. So, like I said, shafts, 99% straight, pretty good. But if you want to get it to be 100% straight, you can use this light method here. All right, so how do you get the shafts on the wheels? So, according to the instructions, you don't want to take a hammer and bash this shaft right up there. So you can use a mallet. They have a little Tamiya mallet that you can get to gently knock the shaft into place. But before you do that, you want to take the shaft and you want to place it right on the wheel on the inside like this. And you want to kind of try to turn it a little bit. And you'll feel where there's a point of resistance. And where that resistance point is, that's probably where you should stop right there and then apply pressure. Gentle pressure, tapping it in place. So what do I use to tap these in place? I don't have a mallet, but what I can use is I can use this, I can use anything that's kind of metal and heavy. So I have here what's called a wheel shaft remover. This is another specialized part, but you can use anything that's a small object, not a big hammer, a smallish object, and just tap this in place like this. Make sure that you've got like a nice solid surface. Remember, start off turning the shaft until there's resistance. And when there's resistance, you stop right there and take some heavy object and tap it in place. And tap it in so much so that it doesn't move anymore, right? So you might need to tap it in. So here, I tapped it in just enough. I can probably just pull this off right now, but I'm going to leave it because it looks like it's solidly in place.
Hey Claire, are you just trying to tap the start in?
Yeah, you're just trying to tap.
You're not trying to put it all the way on. You're just trying to get it started a little
Yes.
bit into the hole, and then we'll show you how to put it on the rest of the way.
So, I'm going to show you a little bit about these things called palm bearings or the wheel bushings. So, depending on which car you have these little circular discs, and they fit into the wheel shaft bearings right there. So they're little donuts. They look like little circles of plastic. Make sure we're going to talk a little bit about that. So these cars, technically, if you just race box stock cars, you're probably not going to spend much more than $15 a car. I think I've seen the cars for $18 at most. But if you get into something that's a little more like advanced, like the tune class cars, and start putting things on them, like bearings and rollers and things like that, a car like this could be, you could add over $100 worth of stuff on your car just to make it like this. But it doesn't guarantee that you're always going to win a race, right? So it guarantees that you'll have a better, more stable car, a faster car, but you want to make sure that all the parts that you add kind of fit in with the philosophy that you have or what you want your car to do, as well as the philosophy of the design of the car too. So different cars will need different sets of rollers and weights on them. Front rollers, front spacers, front dampers. So the dampers are nothing more than these weights right there that slide up and down. And so here's the front dampers, the side dampers, weights in the side, weights in the rear. So that, okay, everybody's got a propeller shaft, right? So we want to make sure that this fits into our car totally properly. So if we were to just place this shaft into our car, if you just take your finger and place it on the middle part of the shaft, and you slide this shaft up and down, there's a little bit of wiggle room there. We want to minimize the wiggle room as much as possible because you want to try to optimize the performance of what's going on inside the car. So if there's too much wiggle, that's a bad thing. We're going to try to minimize the wiggle as much as we can, but not so much that this thing can't move. So this is what I mean by that. We're going to take some sort of mallet or a heavy object, just like we knocked the shaft onto the wheel, we're going to also knock this part onto this end part, these pins, closer onto the shaft itself. So I'm going to walk around and I'm going to show you what I'm talking about before we start.
There's no part of that one if we ever get that.
So yours is too tight?
Tiny, tiny.
Okay, cool. I have this little guy here. And this is another tool that you can get offline.
You were knocking things with it earlier.
This is a Tamiya tool, actually. I think you probably have one.
Oh yeah, that's the
Yes.
pinion puller.
Yes. We need a pinion puller to loosen the pinion. Yeah, it's not moving at all. Take a look at it, slide it around. It looks like it moves. It still moves. That's what we want. We want that little gap. Okay, does everybody have their propeller shaft in place for all the single shaft cars?
What, you got their shaft in place?
All right, so you see here in the instructions for the single shaft cars, you have to put the gears in now. So we have, for me, we've got an orange, two orange ones. You might have a pink one instead of orange, as well as a yellow gear. So please insert those in. All right, so your single shaft cars should generally look something like this. So we have orange gear for FMA, orange gear up there, as well as your counter gear.
Walk around and show these guys.
So instruction number 4 on the FMA chassis cars talk about adding these gears like this. Instruction 5 talks about adding the metal parts to the car, and also the on-off switch. So if you're up to there, build up to the part where you've got the wheels to install next, because we're going to talk about wheel installation. On your FMA chassis, if you've got FMA chassis, if you've built it up to this point where you've got the metal switch in place, only if you have an FMA chassis. We're going to install the wheels next. So, the wheels go in like this. First, you want to lubricate. Take your pen, or your grease, preferably with oil. We were talking about that. You got your wheels on? We're going to do this. You've got an FMA chassis.
Let's see what you're doing there.
So we're oiling the insides of the palm bearings. This lubricates the insides of these palm bearings so the shafts can turn more easily. Remember to try to line up your wheels such that if you've got tires that have little burrs, little bumps on them, try to line them so that those bumps are in the same direction. So, you have the option of pressing the wheels onto the shafts themselves, or a more advanced technique is you can get this thing called a wheel press. And a wheel press is this thing right here. It's like a very sophisticated, expensive device, but you can actually get it for cheap from an outside source, and I'll tell you about this if you're interested. If you're truly interested, come to me and I'll tell you the source to purchase all of these little extraneous devices, because Tamiya doesn't actually sell something like this. So, but people are using these tools to help optimize their cars. So here, I'm placing the wheels right here. Here's a wheel press right here. I'll start this off with this wheel flush up against here. As we tighten, we want to do the wiggle test. We want to have just a little bit of wiggle there. Not too much, not too little. It's almost there. Until we get to a point of resistance. Back off a little bit, press a little bit more. Then when we come on out, we have wheels that are completely in parallel and perpendicular to the chassis. The more perpendicular your wheels are to the chassis and the more parallel the wheels are to each other, the faster your car will be. So, if you haven't put your motor into the motor casing yet, you want to make sure that your motor, your leads, are not flush flat. You want to make sure that there's bent slightly, like this. They should already come slightly bent. You want to make sure that when you place this into the motor cover, that these legs bend inward. So they should be flush flat against contact. So here, I just want to make sure that it's
If it works, then let me do
so here, yeah, we got this in, and this was not bent over, right? This was fine. Okay, so you want to make sure that you're lubricating all of the gears in your car, too.
This is important.
So you can get 1 to 2 extra kilometers per hour on the speed of your car by lubricating all of the gears. So you need to basically grease the ends of the propeller shaft, the gears on the ends of the propeller shaft, as well as here on the other side, the other end, as well as the pinion gear that's on the motor. Get it all the way around, all the way around. So these will...
Turn your wheels as you do it.
Yes, you can turn your wheels as you do it. Naturally, over time, all that grease will get onto the colored gears themselves. And we also have to consider this counter gear here. Gently, gently, just dab a little bit of grease on here. Not too much. If you put too much grease on these counter gears, you're going to get a lot of grease buildup inside the chassis. And over time, all that buildup, all that gook is going to slow down your vehicle. So sometimes you might have to take apart your car and clean out the inside wells where the grease accumulates. So just a very light coating, just like that. So here we have the fifth palm bearing goes right into the speed gear itself, and you push it in place. And now, when this shaft goes through it, then this is a more stable speed gear. A lot more stable than if it were to run without one. When you're inserting screws into the chassis, you take your oil pen and lubricate the insides of the screw holes. That way you'll be able to insert the screws in more easily, and there's less of a chance that you'll strip the screw hole. So you'll find over time that some of these parts will loosen and will come off. And attaching them on and detaching them, it's going to potentially ruin the screw hole. So adding oil to the inside of the screw hole will prevent that. So you've got your batteries in the car, and you turn it on. You want to make sure that there's a smooth sound coming out of your car. It's a relatively smooth sound. When you turn off the car, you want to study the wheels. You're studying the wheels for any sort of wobbling or shelving. The wheels should be pretty much straight. If they're not straight and you see wobbly wheels, your car is not going to be as fast as cars that have straight wheels. Straight wheels mean straight shafts. Straight wheels means you place the wheels on so well that your wheels are parallel to one another and also perpendicular to the chassis. Now the trick with the rollers in the car, very important because this can actually mean the difference between a car jumping out of the track or a car staying on the track. You want to make sure that your rollers are securely fastened onto the vehicle. And what you want to make sure of is that you place the rollers on in such a way that the screws are perpendicular to the plane of the car. So the plane of the car is like this, flat. You want to make sure that the screws are inserted as perpendicularly as possible. So lubricating the rollers, you want to make sure that the insides of the rollers are lubricated with the oil pen. So take your oil pen and just run the oil pen into the inside of the roller. Like So these metal spacers right here, these look like metal donuts. They have a concave part and a flat convex, even convex part. You want to make sure the concave part is on the top. When you're inserting your screws in, there's a method that I always like to use. You don't want to turn this in totally counterclockwise or clockwise. You want to go do what I call a 3 screws in, 1 screw out method, so that you don't you prevent the stripping of the screw by doing this method. So here we go, 3 counterclockwise, 1 counterclockwise, 3 clockwise, guys, 1 counterclockwise. So 3 righties, 1 lefty, 3 righties, 1 lefty. And just continue that way until the screw is securely in place. When you meet that point of resistance, don't do anything with it at all.
The battery is on, but I want to.
So how do you know that your screw is on, the roller is on the screw properly? You want to make sure that when you spin it, it spins freely, and it spins well. And it doesn't just like spin for a couple of revolutions and stop. It should spin relatively freely. And adding a little bit of oil to the inside of the roller, dripping on top of it, that'll also make it a little faster too. How fast your rollers are will determine how fast your car will be around the corners. Okay, turn them on all the way. Ready? 3, 2, 1, go! Awesome time today at this seminar, How to Optimize Your Box Stock Vehicles. We built our wonderful cars. A lot of people brought in their own cars, we built them using all of the techniques that I provided. So yeah, lots of tried and true techniques, lots of secret techniques, pretty awesome. And we got to race our cars on a sample track too. And you know what? Sunday, April 14th, our very first box stock race here, box stock and tune class race at AAA Hobbies. So come one, come all, Sunday, April 14th, 1 p.m. Yeah, hope to see you there. See ya, bye. So yes, everybody, if you like this video, please slam the like button, subscribe to my channel, and you'll see more videos just like this one. Until next time, everybody, see you, bye.